So we've been talking a lot about factoring and factoring, but the question comes up, what if your trinomial can't be factored? And that will happen every now and then. And so when it can't be factored, it's called prime. Okay, we have a prime trinomial. So if your trinomial is in standard form, and you try to think of factors and try to think of factors and you can't, we have this thing called the discriminant. And the discriminant will help us to decide if this trinomial can be factored. The formula is this: b squared minus 4 times a times c. So if it comes out to be a perfect square, then it can be factored. You just haven't thought of all the factors yet. But if it's not a perfect square, then we call the polynomial prime. And it does happen every now and then. So let's go through these examples here. So a is 5, b is 11, and c is 1. Okay, so we want to find out, can these be factored? So it's b squared, always use parentheses, minus 4 times a times c. Okay, and when we do that, you get 101. That's not a perfect square, so this trinomial is prime. Stay tuned for their unit on quadratics, and I'll show you what to do so you can get a solution. So here, a is 1, b is 5, c is 6, so it's b squared minus 4 times a times c, and then we get 25, this is interesting, and we get a 1. And you can factor that. Okay, the factors of 6 that add to 5 are 2 and 3. Now, our next one is a binomial, so please pay attention here, because on this binomial, a is 4, b is 0, there is no x term, and c is negative 9. So it's 0 squared minus 4 times a times c. And when you multiply those, you get 144, which is a perfect square. You can factor that. And let me just show you, when you factor it, what it winds up being. So the factors of negative 36 that come out to be 0 are 6 and negative 6. Okay. Last one here. What are the factors? We want to find out if we can factor this. A is 1, b is 6, c is 5. It's 6 squared minus 4 times a times c, which is 36 minus 20. If that's a perfect square, you can factor it. In fact, this is what it factors to. Okay. That happens every now and then. All right, so now this is kind of new. Wait a minute. We're supposed to factor 4 terms. Everything we've been working on so far just had 3 terms. But the steps are the same, so look real carefully. There's no greatest common factor here. We can't see one. Okay, so now it says group the first 2 terms together, leave a plus, and the second 2 terms. So we're grouping. This is called grouping. Okay, then it says find a common factor of each group. What's the greatest common factor here? It's x squared, and I'm left with x plus 7. What's the greatest common factor here? A 2, and I'm left with x plus 7. And from our notes on the last time, right, this and this are the same. So we take that out. And I don't know why I use the boxes. Parentheses are fine. Usually we write them with parentheses. And remember how to check your answers? You just FOIL it, and you would get the same answer. Oh, there's the answer for that. Sorry. Okay, so this one here, I love, love, love this one because there's a greatest common factor here. You're like, wait, what? Oh, and that's what we mean, factor out a GCF. Factor out a GCF. They are all even, and they all have an X. So I'm going to, we call it take out or factor out a 2x. And as we discussed before, we'll tell you what all that means with quadratics. We're building your skill for factoring right now. So then this becomes x to the third, and this becomes minus 4x squared. Then it becomes plus 2x, and then minus 8. Remember, you look for the greatest common factor of the numbers, and then you take the smallest value of x. And to find out if I've done it right, if you just distribute, you'll get back here. All right. Oh, and then we do the same thing. Group the first two terms together, and then group the second two together. So these two come together, leave the plus, these two come together. So then the 2x stays out there again. This time it's better to use a bracket, keep them out there. And then this would be x squared times x minus 4. And we add the plus, and the GCF here is a 2, and we're left with x minus 4. Oh, they match. That's what we want to see. And if they match, we leave the 2x here, and we write the x minus 4 first. And then remember, these guys come second. Okay, so now we have some practice. It says factor each expression, factor the trinomials, and then use the discriminant. And I think that's a problem too. Yep, and then this one here. So go ahead and turn this off right now, do those problems, and then come back and I will walk you through how to do them all so that we know that you're factoring when you have a polynomial that has 4 terms in it. So here we put the first two together, the second two together. I find the greatest common factor. I find the greatest common factor, which would be 5. I love when this works out perfectly. These are the same. That gets written first. And then we do this. And now I have factored. Factored. Put it apart. Remember, this is called factored form. And this is called standard form. Okay, next one, there's 4 terms. Let's put the first one. I add my plus. This goes here. We find the greatest common factor of the first group. And then it's 3x plus y. And be careful with negatives, because what's going to happen there is you're going to have to take out a negative 4. And then when you're done that, you're left with 3x plus y. And you can tell because negative 4 times 3 is negative 12. Then we have 3x plus y times x minus 4. I have factored it. I made 4 terms into the product of 2 binomials. Factor each trinomial. Okay, so of course you're going to make your little factor puzzle, right? What are the factors of negative 60 that add to 7? Oh my gosh. Oh, okay. One has to be a plus and one has to be a minus. And it's 12 and 5. But it's got to be negative 5 and 12. So this is when we regroup. 3n squared. I'm going to put the minus 5n first, because of sometimes negatives mess me up. Minus 20. And then, oh, we got 4 terms. We put the first 2 together, find the greatest common factor of n. And then we look at the second 2 and find the greatest common factor of 4. I love when these work out. Now, we take out the 3n minus 5, and I'm left with n plus 4. This next one I think is a little hard, because when you make, there's no greatest common factor. You're like, oh, that would have been so much better. So I make my factor puzzle here, and when I multiply these two together, I get 252, and then I got to get 48. Okay, so this took me a little time to figure it out. And so I finally came up with, oh, it's 6 times 42. So we have 7a squared plus 6a plus 42a plus 36. Right? Because these two over here, we replace here. And then I group the first two together. I group the second two together. The GCF here is 6, right? Oh, good, we did it right. 7a plus 6 times a plus 6. There's my two binomials. Use the discriminant. Okay, so this is good to practice. Use the discriminant. Can you factor? Now, you might say to yourself, well, no, I can't. What are the factors of 3 that add to 2? There are none. But you can't just say something's prime. You have to prove it. So in order to prove it, we're going to use the discriminant. We know that A is 1, B is 2, and C is 3. So we do B squared minus 4 times A times C. This is 4 minus 12, negative 8. Oh. So negative 8 is not a perfect square, so we are done. Prime. We've just proven it's prime, okay? You have to prove it. Then our last one, it's a group of 4, right? And so put the first two together, love the plus, put the second two together, find the greatest common factor. Find the greatest common factor, which would be 3. Yes, it worked out. And then we write the d plus 2, and we write the d squared plus 3, and we're done. I do have on this last slide, here's all the answers that were there, in case you wanted to just verify. Next, go ahead and work on the practice that's there, and you should be all set.